Alright guys, welcome back. Here's the question stem here. This is going to be an initial value problem where you solve for a solution function that's going to have a c in it, and then they're going to give you the initial x value and y value, and that's going to allow you to find a specific c value to have a specific solution rather than a general one. So here's the question. Solve the given differential equation subject to the indicated initial condition. So it's all this right here is the differential equation, and it's subject to this condition, which means given x at 0, y as a function of x equals 0. That's the initial condition. So let's just move along here and see how it goes. So first of all, to solve this, can we say that it's a separable equation, a separable differentiation where you separate out on one side the x, one side the y? Can you tell? Well, just quickly, you know from cross multiplication, this can go down here and this can go down here. Let's do that. So sine x, 1 plus cosine x, which I basically just divided by 1 cosine x, so it goes away on the other side, dx equals dy 1 over e to the negative y plus 1. So that was just kind of a quick way to do it. So does that look like it's separated? You have all x on this side and you have all y on this side. So yeah, it is. So now we could try to solve this. So basically, we're solving this equation, and when you get the answer, it's going to be in the form of a generic c. And then you can solve for that c given these initial conditions. That's what we're going to do. So first, let's solve this. So how do we solve this? So we can integrate both these sides because of the way they are. This just got x, it's just got y. So is that hard to integrate those? What do you think how do you think you would integrate those? Well, they get trickier and trickier. But here, if you let u equal 1 plus cosine x, then what's du going to be equal? It's du dx. What is that going to be equal? It's going to equal 0. It's going to be negative sine x. So and then we could bring this dx over here. So we have a negative sine dx in du. But what do we have here? We have a sine x dx. We have a sine x dx, not a negative sine dx. So multiply this by negative 1, which will change that to a positive. Now we have, given the negative in the du, negative in the du, which I just took outside the integration, is sine x dx. And we have sine x dx. There you go. So that's looking good so far. And then we got u equals 1 plus cosine x. We could just do this. 1 over u. And what's this? This is going to be equal to negative log u, which is what? 1 plus cosine x. Then you could do like a plus c. Right? What about on this side? What are we going to do? This side's kind of tricky. Well, sometimes it's really not a good idea to have a variable be negative in the exponent. So what you can do is you can just rewrite this. Looking at this argument here, we can say that 1 over e to the y, that's the same as e to the negative y, plus 1. You can write that as e to the y, e to the y. Now you can add these together, and to bring this down right here, you have 1 over 1 plus e to the y over e to the y. Now this is in the denominator. You can flip this, right? Now you can flip it. So this is going to be e to the y, 1 plus e to the y, dy. Now how about that? Does that look easier to integrate? See how I switched it around and changed it to that? Does this look easier to integrate? Well, just let some complicated part of the function equal u. Let's let u equal 1 plus e to the y. Du equals e to the y dx, or dy, because we're in y right now. Okay, so that looks pretty good to me. Put du right here. You got e to the y dy. You got e to the y dy right there. I got that in my du. Now I got to put this argument is just u. So 1 over u. Alright, now what's this going to be? This is going to be the natural log of u, but u, there we go, u equals 1 plus e to the y. 1 plus e to the y. Do we have to use absolute value signs? No, but this can never be negative. Doesn't care. I don't care what value you pick for y, it'll never be negative. It'll never be 0. So, let's go ahead and move on to another piece of paper. We have now, what we have now, if you look at it down here, right here, we have this, we solved, and it's right here. So we've got negative log 1 plus cosine x plus c, our constant of integration. On the other side, equals log 1 plus e to the y. Alright? And just to note, there's a restriction on x. X can't be 0. X can't be a value which makes cosine x equal to negative 1, which is, I think it's pi, plus c. Now we could just add these c's together on one side and just call it c. So there's our c. There's our c. So, now what do? Well, what you don't do is enter your initial value conditions yet. The first thing you want to do is solve for y. You got to solve for y, or at least close to it. So we could bring this up here and raise e to this and raise e to this whole thing here. What do we got here? We got 1 over 1 plus cosine x. Okay, we won't need this paper anymore. Right? And then this equals, because this is, the negative goes up here. Remember, it's a property of logs. And then these are inverse functions. So the argument comes down and it's to the negative 1, which is this. Is that clear? And then what about this right here? This is going to be e to the natural log 1 plus e to the y times e to the c. Right? Do you understand where that came from? Because this is e raised to the whole thing now, log quantity 1 plus e to the y plus c. So when you multiply e to the log 1 plus e to the y, and you multiply it by e to the c, you're going to get e to the log 1 plus e to the y plus c. Okay, alright, so then this goes away. So we got 1, because these are inverse functions, we got 1 over 1 plus cosine x equals 1 plus e to the y, e to the c. Now what? Now we can multiply this over here. We get 1 and divide by e to the c. 1 over e to the c equals 1 plus e to the y, 1 plus cosine x. Now this is pretty good at this point. Now we can put in our initial values. So do you remember what it was? It was this. X equals 0, so we'll plug up x for 0 and y equals 0. Right? So we got, and what's this? This is just another constant. That's going to be our constant final. We'll say that's our constant final. The final constant equals 1 plus e to the 0, 1 plus cosine to the 0. This is 1. 1 plus 1 is 2. This is 1. 1 plus 1 is 2. So our constant final equals 4. 2 times 2 equals 4. So we just write it in right here. So we've got 1 plus e to the y, 1 plus cosine x equals 4. See, this is what we're messing with. We could have done it up here, and we could have put our initial stuff in there, but then we would have had left it like this, and we would have gotten this C over here, which is only associated with this equation. Here's a more finished equation right here, where we have 1 over e to the c. It's more nice right here. So that's associated with this equation. Therefore, I wrote it with this equation. Here you go.